Today we'll start with Docker, then we'll go to Jenkins, right? So this is the agenda for today. I'm going to discuss what is the difference between physical server, virtual machine, and then Docker container. So we'll see what is Docker, and then where Docker comes into picture in DevOps ecosystem. And then you understand why we use Docker and then Docker advantages and things like that. Then we'll see Docker supported platforms, where Docker is supported, and what are the requirements to run Docker on your machines. Then we'll also install Docker, and then we'll start getting the containers. Okay, so to better understand what is Docker container, first we should know what are the limitations we have with respect to physical machine and then virtual machines. Then we'll see how Docker containers are better than physical server and virtual machines. Okay, if you have taken the demo class, this is what we discussed. Assume that this is you, okay, and you have a machine. It's a physical server, okay. So this is your RAM. This is the RAM you have, and then this is the CPU, and then hard disk drive. Any questions? Somebody is on that? Okay, this is you, and it's a physical machine. Okay, so assume that you have say 8 GB RAM, and then you have octa-core processor, 8 virtual CPUs, and then say 500 GB hard disk. Just think in that way. This is your friend. Your friend also has a mission, and then this guy is working on some updates, some projects. So he wants to execute his project on 2 more machines. So he requires 2 more machines basically. He wants to run database on one machine, and then say some services are front end on another machine. So this guy has to go and buy 2 more machines, correct? Before he buys 2 more machines, he'll come to you. He'll say, can I use your machine? You say, this is my computer, I also need a machine, so I cannot give my computer to you. Then he will ask you, okay, fine, can I ask you a few questions? Yes. How much RAM you have? 8 GB. How much hard disk space you have? 500 GB. And then 8 virtual CPUs, octa-core processor you have. A simple question he will ask you, are you using this computing power? We call these 3 together as a computing power. These 3 decides computing power of your machine. This guy says, I hardly use 2 GB RAM and then say 100 GB hard disk, and then maybe my applications use 2 core or 3 cores, right? Then the next question he says, since you have already invested a lot of money in buying this hardware, and I also need 2 more machines, and then I have to again buy hardware for these machines and then assemble and then use it. So he says, since you are not using it, can I use this computing power? Can you share unused computing power with me, so that I will install OS on top of unused RAM CPU hardware, and then I will run my applications, maybe DB or things like that. Then you tell him, it's a physical machine, I cannot share this unused computing power with anybody. Once hardware is attached to this, whether you use it or not, you have to, right, say whether you use it or not, you have to dedicate that to that mission, right? So you cannot basically reuse the computing, basically utilize the unused computing power. So this guy has to buy 2 more machines. That is the problem of physical machines. This laptop has 1 TB. Am I using 1 TB today? No. So this will lead us to spend more money, and then a lot of hardware is lying unused. That's where people came up with something called what? Virtualization technology. So if you have to use virtualization technology, you go and then install some virtualization software. Say for example, you have the operating system. On top of OS, you have to install some virtualization software here. Say for example, Oracle VirtualBox or VMware Workstation, or it can be anything. In your laptop, currently what you have the Windows, and if this virtualization software, you have installed Oracle VirtualBox, right? Using that, you have created the Linux machine. If the software was not there, right, you have to buy another machine for your DevOps practice. One for Office, that is Windows, one for Linux for learning DevOps. See, this virtualization software helped you to create multiple machines on top of the same piece of hardware. So you install some virtualization software, and then using that you can create multiple machines. That's how you utilize the computing power to its max capacity. If you are creating a machine using virtualization technology, you call it as VM, virtual machine 1, virtual machine 2, and then virtual machine n. You can create n number of virtual machines. And how these virtual machines work? You don't need to buy the hardware for this. This virtualization technology distributes the same hardware that you have in your host. We call this as a host machine to these machines, to these VMs, and you have to just install operating system on top of that. So this virtualization software distributes the same RAM, CPU, hard disk to all these machines. Correct? Okay. Virtualization. This virtualization software virtualizes the hardware for multiple machines. And then you can run your application 1 here, application 2, application 3, and things like that. Correct? So virtualization technology is helping us to maximize the usage of computing power. You can create multiple machines on top of the same piece of hardware. So in this particular scenario, your friend would have just installed virtualization on your machine. You can use this host, and your friend also can run multiple applications, one database here and then things like that. So you don't need to basically buy new hardware. Virtualization technology is very popular even today, but infrastructure is moving from virtualization to containerization. Companies are moving their infrastructure from VMs to containers. What is that? Why? Let's compare virtualization with Dockerization, or you call it as containerization. Assume that here also you have the same machine. This is your host. On top of that, you go and install some operating system. Then here you have to install a containerization software, that is Docker. This is Docker. And you have the OS, and then you have some hardware here, right? Assume that you have the same piece of hardware, RAM, CPU, and then hard disk drive. Okay. Using Docker also, you can create multiple containers like this. If you are creating a machine using Docker, you call it as what? Container. We don't call it as a Docker container, container itself. Okay. Container 1, container 2, container n. Right. Docker also virtualizes the hardware for us. You don't need to buy a dedicated hardware for all these machines. Okay. And you have the OS. You install the OS here, and then you can run your applications. Correct? Right. So this is the OS. Now, when you can create multiple machines, right, using VM, why people are moving to containers? That's the question, right? Let's compare virtualization with containerization now. Very simple. So if you have created the VM, you know how to create the VM, right? You know this. To create the VM, one second, let me just more time, less time. So you know this. To create a new VM, right, we have to install operating system, correct? We have to install a dedicated operating system in each and every VM. So that's how we have created the VM, right? So operating system means it's a 2 GB size code is sitting in each and every machine. Since each and every machine has OS, right? It takes more time for you to create a new machine, correct? It takes more time for you to create a new machine. You have to wait at least 5 to 10 minutes to install the operating system, then only you, create a machine. It takes more time for you to start the machine, because you see just now I have started Linux, correct? The VM, how much time it took? Starting, it runs a lot of command, right? So that is what? It is booting the operating system. It is loading the operating system code, and then that's how your machine is coming up. So you have to wait for the operating system to come up because you have OS in each and every machine. It takes more time to shut down your machine because there is a operating system. You have to install OS. If it is container, right? So you don't need to install operating system in each and every container. First thing, right? You don't need to install operating system. First thing. And containers don't have dedicated full-blown operating system, a full copy of operating system. Containers don't have, the physical copy of the operating system. No, you don't need to install, and okay, you don't need to install, right? So when you are not installing OS, correct? How the container is getting the operating system, correct? So containers don't have dedicated version of operating system. That means if there is no operating system, how you run applications, correct? If you want to run the applications, you need to have the operating system, and you are not installing it. So the question comes, how Docker is managing, right, to give operating system kind of environment to this container. That's the beauty of Docker. Even though you're not installing the operating system, Docker creates OS kind of environment here virtually. So here in virtualization technology, your hardware is virtualized. Virtualization means which is not present physically. You don't have physical hardware for these VMs. You are using the same thing. So virtualization technology is virtualizing only the hardware. Whereas you can think Docker virtualizes the hardware as well as what? Operating system also. And it is virtual. It is not the full copy of the operating system. Understand this? Containers has operating system, but it's not a physical copy of the operating system. No, right? It is OS kind of environment, virtual operating system. So there is a difference, right? Having the full copy and then having OS in a virtualized way. It doesn't take, say 2 GB, say hard disk space, right? And OS means what? It will also use RAM, CPU, and things like that, right? Here, you don't have a dedicated copy to run your operating system code. That is C, that is written in C, right? So Docker gives you a feel that you have the OS, but actually speaking, containers don't have physical copy of the operating system, right? How it does this? Docker has two core features called namespace. Namespace. And then there is another field, another feature called C group. It's not actually Docker features, it's a OS. In Linux, right, kernel, you have two features. One is namespace and then C group. Using namespace technology, you know what it will do? It will, right, even though you don't have a separate operating system, using that namespace, it's like, if you know the coding, in coding you have something called threads. You can fork multiple processes of something, right? So you just, say do something, multiple times, right, in parallel kind of things. So using this namespace technology, which is available in your Linux kernel, what it will do, even though there is no operating system, it will make sure that this particular mission has a separate IP. Separate IP means it becomes a separate mission for you, right? Usually when we have the operating system manages all these things, like it gives a separate IP for you. It gives a separate networking capabilities, right? So that whatever applications you're running here, right, other applications cannot connect to it, or you have, say control over it, right? What applications can connect to this and what applications this application can connect to, basically, right? You can define all those networking rules as if you have operating system here, correct? So Docker gives a separate IP address using this namespace feature. It gives a separate networking capabilities. It gives, separate, say for example, process tree. That means if you are running 10 applications here, you don't see these 10 applications here. That means what? It's a separate mission, right? You have the boundary, basically. You call this as a user space. What is that? User space. That means it gives you operating system kind of space, right? So it gives everything, process tree, storage capabilities, everything. So you feel that it's a separate operating system. you feel that your application is running on a dedicated copy of the operating system. So who does all those things? Docker, right? And using this C group, it will distribute RAM, CPU, hardware for all these things. It knows, right, how to limit the hardware, how much RAM it has to distribute to this CPU, hard disk, and all the stuff. Okay, that we'll discuss later. That's a separate topic we have. Okay, basically Docker uses Linux kernel's two core features called namespace and then C group. Using these two features, it will manage operating system kind of environment here, so that you can run your own applications, right? Like a dedicated mission. You call it as a user space, or people also call container this way. You can think in a way that all these containers run under same operating system. You have only one copy of the operating system, right? These containers run under same operating system, or you can also say these containers are just kind of the processes. It's one process, that's all. It's one process for your host mission, right? It just acts kind of a process. In this process you have application running, and in this process you have that application isolation, right? So separate networking, IP, process tree and everything, just a process, that's all. So this, for this host mission, this container just becomes kind of a process. So here the conclusion is containers don't have full-blown copy of the operating system. It's a virtualized operating system kind of environment. Understand that? Since there is no operating system here, right? You can create a container within less time. It takes less time to create a new mission because you don't need to install operating system. It takes less time for you to start the mission. You don't need to wait for operating system to come up. In fact, you can create a container within less than 1 second. See this. Within less than a second, you can create a mission. How much time it took for you to set up, to create your VM? 5 to 10 minutes, right? It takes less time to stop the mission because there is no operating system, right? Okay. So that's a beauty of that's a beauty of Docker. So one thing here, you, without any doubt, you can consider your container as a separate mission, as if a full copy of the operating system is running, but actually speaking, not, right? It gives you all those luxuries, right? Like what you get by having the operating system. So if you get IP, network, process tree, and all the stuff, like why do you bother whether you have the operating system or what? And you just leave that to the Docker. That's the technology that Docker is, Docker provides us. Okay. So it takes less time to create start stop. Here it is more time. There is another, the major advantage, right, of Docker compared to VM. See here, there is one more thing. Since you have a separate copy, 2 GB code is sitting in your machine and then running. It's an operating system. That means it's a code. Code also uses RAM, CPU, hard disk. Correct? So by having a separate copy of the OS, you are wasting a lot of hardware. Isn't it correct? So your operating system is also using this computing power. Here, since we don't have full copy of operating system code running in each and every mission, you don't need to waste much hardware here. Correct? So we call VM as heavy. This is heavy because it's a costly. It takes more, it consumes more computing power, whereas container is lightweight. It doesn't take much hardware for you to create a container. Simple example, as I always give, you buy 64 GB mobile. Do you get 64 GB space? No, 60 GB. Where is remaining 4 GB? That is occupied by your iOS or Android or whatever it is. Same thing, right? In case of laptop also, right? So operating system occupies some computing power. So see how you are wasting the computing power. Okay. One more thing here. So we call it as heavy, right? Say for example, on this hardware, 8 GB, octa core 500 GB, maximum how many VMs you can get? 5 VMs. Now you right? Say maybe already experiencing it. You have one VM and then your host machine becomes slow. Maximum you can create 5 VMs, and with 5 VMs your host will become slow. If you can create 5 VMs here, you can create 50 containers. See the difference? You can create 50 containers because you're not wasting much hardware, right? Google kind of companies, right? So to run their search, Gmail, Google file system, drive these kind of applications, right? They need billions of machines, billions, right? See now, when you have that scale, right, requiring billions of machines, can you afford to have VMs? If it's a container, right, using less money, you can create more and more machines, and then it's right with these advantages like create, start, stop becomes very fast. And if you want to scale up the infrastructure, assume that it's a big billion day or Amazon between their sales or Thanksgiving day, you have to scale up your environment. You have to add 100 more machines to your production environment. How much time it will take for you to add 100 VMs? How much time it will take for you to add 100 containers? You can create the containers within less than a second. It is not just creating a mission with your application code and then all the prerequisites, dependencies. With all those things, you can create a mission. That means within 1 second, you create a mission where you have your say JDK, Tomcat installation, your application warfare deployment, Tomcat server is also running. So within 1 second, you see a mission where your application is configured and then running, right? That is also possible. That is possible using something called Docker images, right? We'll talk about images later. That's a separate topic. Okay. These are the major differences between a physical machine, a VM. See, in physical machine, right? Once you attach the hardware, it is only for that. You waste a lot of hardware. In VM, you can utilize the hardware to its max capacity. You can get multiple machines. In container, you can do the same thing what Virtualization is doing in a efficient way. It's a lightweight compared to the VM. So there is no operating system installation. I mean, operating system installation is not required. You are getting OS virtually. You feel that there is a OS, but actually speaking, there is no full copy of the OS. Right? These are the major differences. And Docker also has, as I said, image concept where you can create a machine within less than a second, and you have everything out of box, your code, prerequisites, and everything. So we'll talk about that later, right? Okay. I'm going to, okay, before I take the questions, after this, I'm going to explain. If I have the Linux here, can I create Windows? If I have Linux Ubuntu, can I create CentOS, RHEL, or any other operating system? If I have Windows, can I create Linux? So I'll discuss all those combinations. And before that, okay, questions. Go ahead, Prasanta.
So you're telling that Docker, there is no OS, that is a virtual OS. What exactly virtual OS do then? See, one application run means it requires some application support application and so on. So what exactly that virtual OS keeps? You're telling that is
Okay.
not original OS, that is a virtual OS.
Correct. So virtual OS means you get all OS capabilities. If you have a OS in one machine, if you have a OS in one machine, for example, what you get? You get a separate IP. You can control the networking things, correct? Say when you are running some application here, you can basically using firewalls, DNS, and all those things. You can stop other machines to connect to it. So by having the OS, you have the control. You can control the network part, right? And any other machines can connect to this, locate this machine using its IP address. It has its own IP address. It has its own network interface basically. That's a OS thing. And OS gives you what, right? Isolation, right? So if I'm running 10 applications here, you don't see 10 applications in other machines. All these things, right? You get because of the OS, because there is a OS, there is some logic running in your mission. There is some logic running on top of the hardware, that is OS. That OS logic is giving you all these things, and you are getting all these things without having installing the OS. Correct? How that is doing? It's a Docker. So Docker, for example, the moment you create a container, it even though there is no OS, it will make sure that this container gets its own IP address. It does it, using all those, C code, the logic that you have in your operating system, right? That feature is this, right? And if you can also, so control that networking part. How it does? It's a that's a technology they have built. logic they have written in their Docker code basically, which is written in C, right? So all those things. Go ahead, Prashant.
So
Yeah.
now in my virtual box, what is there, Oracle virtual box, when again I will clone one more, this one VM. So what will happen now? It will create another OS, everything.
Here,
Yes, my Oracle virtual box.
correct. If you want to, I mean, in this VM, you meant to say,
Yes.
like you
Now I
have the
have
VM,
Ubuntu only one virtual box. Suppose I will try to clone another, means it will create everything OS again, everything hardware.
right? Everything. So this gets only the hardware from the host, but OS, right? It's like you are installing the logic. The 2 GB code is running there. Here 2 GB
Okay.
code is not running. So here you have the physical OS.
Okay.
See, that's a logic. Say for example, like if you know threads concept, for example. Say for example, I have one Java program running, right? Java program running, Java instance, a command is running. Without installing the code again, you can just fork this particular process, create two Java instances, as if Java is what? It's a piece of code, right, which is running in your machine, correct? So without having another copy of the Java code, same copy will act as two Java copies, two Java instances. You can do that. Forking, we say. They must be doing the same thing.
So it is open source
There's-
or it's a license based, sir? This Docker.
Docker is open source.
Okay. And second, my question is, when it is open source and we are creating a multiple machine, so is it secure?
Yes, it is secure. So it's like if you see Google, right, say is running their search, Gmail, everything on the containers only. It's like you have a separate mission, as if like if you have the OS, again OS gives you all the security, right? For example, if you have the OS, you can control who can access root, who cannot access root, and all those things. Here also, you can control all those things, who can access root and all the stuff, ports, port numbers, and everything. It's secure.
Okay.
Google uses containers. Google, I mean, I mean, most of the companies started using containers 6-7 years back, right? Actively. Google started using containers, 12-15 years back, and then most of their applications are running on containers only now. So you don't need to worry about the security. It's like you have a dedicated OS there.